Alright, so good afternoon to everyone. Let me start by apologizing for the late start. We had some technical challenges that we had to resolve. So we were able to resolve those challenges and we are ready to start. Alright, so I want to, of course, start by saying Happy New Year to each and everyone. Thank you for being on the live today. The purpose of the live moving forward is to help to prepare students for the CSEC exam in June of this year. Every Saturday moving forward, I will be having sessions from 1 to 3, 2-hour sessions. And those 2-hour sessions, of course, will be based on all topics that we need to know to prepare for the CSEC examination. You will see where the session can be accessed through the platform madetickets.com. And also there's a trivia, right? A trivia, math trivia, where we will be able to answer questions on topics that we are going to look at in every session, all right? The trivia can be found in the description in this YouTube channel. So the link to the trivia is under the Math Mania section. So when you go in the Math Mania section, you're going to see the link to the trivia and you can try those questions to test your knowledge on what we are going to look at today. So all in all, it's in preparation for the CSEC exam, and let us make sure that we tell everyone that we know, tell our friends to join on Saturday from 1 to 3 to be a part of the session, all right? So what we're looking at today, we're going to start off with number theory. Next week we'll get into set theory, and then we'll get into consumer arithmetic, and then you have algebra function. So we have a nice process in covering all the topics that we need to know in preparation for the CSEC exam. So we're starting with number theory today. And the topics under number theory we want to look at will be fractions, decimals, indices, percentages, decimal places, significant figures, standard form, ratio, and proportion. So we're going to look at some of these topics today. I know time is against us, but we're going to look at these topics today. And we're going to start with fractions. Reviewing our fractions and showing that we're clear on our fractions. So starting with this first question, using a calculator, otherwise calculate the exact value of 2 1/3 plus 1 1/5 all over 6 2/5, giving your answer as a common fraction. So to treat with such, we have 2 2/3 plus 1 1/5 all over 6 2/5. Of course, in dealing with fractions, once we have mixed numbers, I will always advise students to convert all mixed numbers to improper fractions. So this will be 3 by 2 is 6 plus 2 will give us 8 over 3 plus 5 by 1 is 5 plus 1 will give us 6 all over 5. All over 5 by 6 is 30 plus 2 will give us 32 all over 5. What we want to do next is to work out what we have in our numerator. So in our numerator, we have 8 over 3 plus 6 all over 5. And what I'm going to do is just create a working column here, and I'll place 8 all over 3 plus 6 over 5. You know when we are adding or subtracting fractions, the first thing we need to do is to find the LCM. The LCM of 3 and 5 is 15, so I'm going to say 3 into 15 is 5. 5 by 8 will give me 14, plus 5 into 15 is 3, and 6 by 3 will give me 18. So 40 plus 18 will give me 58 all over 15. So in my numerator, when I worked in my numerator here, the result is 58 all over 15 over what is in my denominator, which is 32 all over 5. Now 58 all over 15 divided by 32 over 5 can be rewritten and expressed as 58 all over 15. What is on top will be written first, the vinculum, the line separating the two fractions, will be your division operation. And what is in the denominator, 32/5 will be written after. And we know in dividing two fractions, we leave the first fraction as is. We change our division sign to a multiplication sign. And the second fraction we invert to become 5/32. From here, when we are multiplying fractions, we look to see what factors are common to both numerator and denominator. So I can comfortably say here, 5/5 is 1, 5/15 is 3. I also look to see what other factors are common to both numerator and denominator. I can say 2 into 32 will give me 16, and 2 can go into 58 to give me 29. Yeah? And I'm going to get here 29 by 1 is 29. All over 3 by 16 will give me 48. So the result of that question will be 29 all over 48, and ensure that we understand the clear steps to help us arrive at that answer. Let's look at another example. So we're looking at different variations of questions involving fractions. So this is a revision exercise to strengthen our knowledge of number theory. So we have here next 1 3/4 in brackets squared divided by 3.5. So let's look at that. So we have 1 3/4 in brackets squared divided by 3.5. So again, where we see mixed numbers, we can convert all mixed numbers to improper fractions. So I'm seeing a mixed number here. 4 by 1 is 4 plus 3 will give me 7/4 in brackets squared divided by 3.5. So 3 by 2 is 6 plus 1 will give me 7/2. But 7/4 squared, it is the same as 7/4 times 7/4. That is what 7/4 squared represents, divided by 7/2. So we know from the rules of BODMAS, we're going to work what's in brackets first. So we know 7/4 by 7/4 will be 7 by 7 is 49 all over 16 divided by 7/2. And when we're dividing fractions, remember we leave the first, maintain that order, we leave the first fraction as is. We change our division sign to a multiplication sign. And the second fraction we invert to become 2/7. So we are going to say here now, again, looking to see what factors are common to both numerator and denominator. We are multiplying, so I can say 2 into 2 is 1, 2 into 16 is 8. I can say 7 into 7 is 1, 7 into 49 is 7. So our result here will be 7 all over 8. So ensuring that we can apply the relevant steps to help us with our fractions. Okay? Let us look at another Alright, so let's look at here. Next, we have the following. So looking at different variations. If we have 1 3/4 subtract 1/8 plus, and in brackets we have 5/6 divided by 2/3. This will be 1 3/4 subtract 1/8 plus and in brackets 5 over 6 divided by 2/3. So again, what are we going to do here? We're going to work what is in brackets first. We have two sets of brackets. So before we even work what is in brackets, let us convert any mixed numbers we see to proper fractions. So I'm going to say, I said a mixed number here. So 4 by 1 is 4 plus 3 will give me 7 over 4. Subtract 1 over 8 plus 5 over 6 divided by 2/3. Again, we're going to work what is in each bracket because from our rules of BODMAS, we know brackets will be implemented first. So let us work what is in brackets. We have two sets of brackets. So this will become 7 over 4, subtract 1 over 8. Again, once you're adding or subtracting fractions, the first thing you do is find the LCM. So the LCM will be 8. I'm going to say 4 into 8 will be 2. 2 by 7 will give me 14. Subtract, I'm going to say 8 divided into 8 is 1. And 1 by 1 will give me 1. So I know in my first bracket, the result there will be 13 all over 8. Let me work out what is in my second bracket one time. So this will be 5 over 6 divided by 2/3. And when we are dividing two fractions again, what do? We leave the first fraction as is. We change our division to a multiplication sign, and then we invert the second to become 3 over 2. So we are now going to implement our knowledge of multiplying fractions. We're going to see what factors are common to both numerator and denominator. I can say 3 into 3 is 1, 3 into 6 is 2. There are no other factors common, so I'm going to multiply 5 by 1 to give me 5. 2 by 2 will give me 4. So in continuing, I'm maintaining the order of the question. So in my first bracket, the result of that, which is 13 over 8, will be written first. My addition sign will be written after, and 5 over 4 will be written next. Making sure we maintain the order. And in adding fractions, again, we know we must find the LCM. So we're going to find the LCM of 8 and 4, which is 8. I'm going to divide 8 into 8, which is 1. 1 by 13 will give me 13. Plus, I divide 4 into 8 will give me 2. 2 by 5 will give me 10. And 13 plus 10 will give me 23 all over 8. Yeah? But I can convert into a mixed number. I know 8 into 23, 8 by 2 is 16. Yeah? And 16 from 23 will give me 7. So I have 2 and 7/8. Making sure we are clear on how to answer these questions, making sure we are clear on the relevant steps to arrive at the correct result. Alright, let's move on to another. Alright, so we move on to another. So we have here 5½ divided by 3 2/3 plus 1 4/5. And And so there's often have challenges when no brackets are involved, because you know normally when brackets are involved, you normally start with brackets first. So when no brackets are involved, students become a bit confused, but don't be. We're using the rules of BODMAS, the format of BODMAS. So we have 5.5 divided by 3 2/3 plus 1 4/5. Given your answer as a fraction in its lowest term, so the first thing we do is to convert all mixed numbers to improper fractions. So this will be 2 by 5 is 10 plus 1 will give me 11 all over 2, divided by 3 by 3 is 9 plus 2 will give me 11 all over 3, plus 5 by 1 is 5 plus 4 will give me 9 all over 5. And from our rules of BODMAS, we know that division comes before addition, right? So we are going to divide, our division operation occurs between these two fractions. So we're going to divide those two fractions first. The result we add to 9 all over 5. So this will be 11 all over 2 divided by 11 all over 3. I will leave my first fraction, as is. I change my division to a multiplication sign and I invert the second. So remember the rules of division. So this will be 3 all over 11, right? The rules of division of fractions. And now multiplying again, the rules of multiplication of fractions. I look to see what factors are common to both numerator and denominator. So I can say 11 into 11 is 1, 11 to 11 is 1. There are no other factors common, so I can multiply 1 by 3 to give me 3, 2 by 1 to give me 2. So I have 3 over 2. And we maintain the order. So the order will be the result of dividing those two fractions first. We write that result first, dividing plus 9 over 5. And in adding two fractions, we know we must find the LCM, which is 10. So 2 into 10 is 5, 5 by 3 will give 15, plus 5 into 10 is 2, 9 by 2 will give me 18. And I know that 15 plus 18 will give me 33 all over 10, and I can convert that from an improper to a mix. So I know 10 by 3 is 30, and 30 from 33 gives me a remainder of 3. So I have 3 and 3/10 as my answer for that question. So let us not get confused if no brackets are there. We simply follow through on our rules of BODMAS. So let's look at next. Right, so let's look at a fraction question in a problem solving format. And let's see. So I'm going to erase here and let us So, Mark spends 3/8 of his monthly income on housing. So 3/8 of his income goes towards housing. Of the remainder, he spends 1/3 on food and saves what is left. So of the remainder, he spends 1/3 on food and saves what is left. Calculate the fraction of his monthly income spent on food. So we want to determine what is the fraction of his monthly income spent on food. So we have Mark, 3/8 of his monthly income is housing, and the remainder of that. So after he takes out 3/8 from his overall salary, the remainder of that, 1/3 of that remainder is spent on food. And of course, he says what is left. Okay? So the first part of this question asks us to calculate the fraction of this monthly income spent on food. So let us consider Mark's monthly income to be a whole, which is 1. Now, 3/8 of his monthly income is spent on housing. Yeah? And the remainder is spent on food. So, let's consider Mark's salary. So, Mark's salary, let's consider that to be 1 whole, right? And housing, so 3/8 of his monthly income is on housing. Good? So 3/8 it goes towards housing. So what is the remainder? So we take 3/8 from the whole, that will give us the remainder. So housing is 3/8. So the remainder, of course, will be to subtract 3/8, because we're taking housing from the whole. It's going to be 1 subtract 3/8. 1 subtract 3/8 is the same as, if you want to write 1 as 8/8, no problem. Or if you want to write it as 1 all over 1, subtract 3/8. I'm subtracting 2 fractions, so I find the LCM. If you want to do this way, no problem. So 1 into 8 is 8. 8 by 1 is 8. Subtract 8 into 8 is 1. 1 by 3 is 3. So the remainder will be 5/8. Not so? But it states here he spends 1/3 of the remainder, 1/3 is spent on food. So then what is to calculate the fraction of his monthly income spent on food? So for part 1, so this information was necessary first to help us to determine the result for part 1. So of the remainder of, which means multiplication, 1/3 is spent on food. So food is basically 1/3 of the remainder, which is 5/8. And 1/3 of 5/8 will give us 5/24. So calculate the fraction of his monthly income spent on food. And now this is the fraction of his monthly income spent on food. Good? And part 2, calculate the fraction of his monthly income that he saved. So what fraction of his monthly income he saved? Okay, so we know that 3/8 of his monthly income went into housing. So 3/8 went into housing. And we know that 5/24 went into food, of his salary went into food. Okay? So we want to determine what is left. So 3/8 went into housing, 5/24 went into food. What is left? So to determine the amount saved, first let us determine what was spent. So amount spent. So the amount of money spent, 3/8 went into what? Housing. Plus 5/24 went into food. So this is what was spent. So when we take away what was spent, when we take that away from his overall salary, we're going to have what was saved. So amount spent will be 3/8 plus 5/24. Let's add these two. So we know when we're adding fractions, testing your knowledge of fractions again. Then we added, we multiplied, we subtracted. Testing our knowledge, we're adding the LCM of 8 and 24 is 24. So I'm dividing 8 into 24 will give me 3. And 3 by 3 will give me 9. Plus, I'm dividing 24 into 24 is 1. 1 by 5 will give me 5. Yeah? And 9 plus 5 will give me 14 all over 24. Which we can simplify. We can say 2 can go to 14, 7. And 2 can go to 24, 12. So this is the amount spent. So what we're going to do is to take what was spent away from his overall salary. Good? And we are going to be left with what was saved. So the amount saved will be to subtract 5 over 12 from his overall salary, which is 1. 7 over 12, sorry, from his overall salary, which is 1. And that will leave us with the amount he saved. So this will be so I'll continue up here. This is the same as 1 over 1. Subtract 7 over 12 minus 7 is 12. So 1 into 12 is 12. 12 by 1 is 12. Subtract 12 into 12 is 1. 1 by 7 is 7. And I know 7 from 12 will give me 5 over 12. So 5 over 12 will be the amount saved as a fraction. So for part 2, the amount saved as a fraction will be 5/12. So you can see questions like this where they will give you fractions in a problem solving format, and you want to make sure you can answer comfortably when given a question in a problem solving format. Alright? So let's move on to decimals. So under number theory, we're looking at topics that we certainly see on a regular basis, and we want to be able to answer those questions in relation to those topics comfortably. So let's look at decimals. Alright, so decimals. And what I will do, so the good thing with CXC and decimals, if you can use your calculator, I ask you to use your calculator in the structured paper, right? Not the multiple choice, but in the structured paper. So we have here our decimals, let's see. So using a calculator or otherwise, calculate the exact value of what we have in that question there. This is in brackets 2.67 multiplied by 4.1 subtract 1.3 squared. So we can use our calculators, we can work what is in brackets first. We know 1.3 squared is the same as 1.3 times itself. So we want to rewrite this as 2.67 times 4.1 subtract 1.3 by 1.3. Now even though they ask you to use your calculator, some students may take the entire question, punch it into their calculator, put it into their calculator, type it into their calculator, and the answer they get, of course they would state that as the answer, but CXC, they like to see steps, even though you are required to use a calculator for such question. So the steps will be to show when we work out 2.67 times 4.1 to give us 10.947 subtract 1.3 times itself. 1.3 by 1.3, which will give us 1.69. And let us subtract those two decimal numbers now. This will be 10.947 947 subtract 1.69, which will give us 9.257. And that is a result. Simple use of the calculator, but again showing steps. So for paper 2 in June, so that's what I've already done in January exam. But for June, you show your steps. So let's move on to another. So if we have this, using a calculator, otherwise, calculate the square root of 2.891 plus 1.2 all over 1.31 in brackets squared. So this will be so we have here the square root of 2.891 plus 1.2 all over 1.31 in brackets squared. Again, we want to show all steps. So I'm going to find the square root of 2.891 and I'm going to show what is the result of that. I'm not going to put the entire thing into the calculator, get my answer and state what is the answer. Show step 6, you want to see steps, right? So this will be, I go to my calculator, square root of 2.891, which will give us 1.7. Now, of course, we have 1.70029. Now, normally, in treating with questions as such, normally treating with questions as such, what I will normally advise, and CXC will normally state it in the instructions, where you can represent your answers to 3 significant figures. If it's not stated, you can represent it to 3 significant figures. So 2.891, the square root of that will be 1.700294092. And what we can do is to, instead of writing all those numbers, we can simply represent or approximate 3 significant figures. So we have, this is what we have. We have one, this is on the calculator, 1.700294092. Now if you want to write down all the digits you can and then approximate the final answer, no problem in doing such, right? So you can write down all the digits and then approximate the final answer correct to 3 significant figures. So if you want, we can do that. So we can write 1.700294092 plus, this is 1.2 all over 1.31 by 1.31. So if I say 1.31 square, we know it's 1.31 times itself. So let's work this out. This is, let me work out what is 1.31 by 1.31. So I'm going to get here 1.700294092 plus 1.2 all over 1.7161. Good? I'm going to divide those two decimal numbers now, then add it to what I have as my first decimal number, and then I will approximate my final answer, even though they did not ask you to approximate, they didn't ask to approximate anything. Right, so they didn't ask to approximate any number of decimal places, and that is something we're going to be looking at today, decimal places, significant figures. But we're testing our knowledge here with, decimals. And we have to add them, subtract them, square them, find the square root, and so on and so forth. So let's work this out. This is 1.2 divided by 1.7161. So we're going to get here 1.700294092 plus When I divide these two, I'm going to put all the numbers on my calculator. 0.6992599949. I'm going to add those two, and I'm going to represent my answer correct a number of significant figures. Yeah? So this will be 1.70294092 plus 0.699259949. I'm going to get here 2.399554041. Alright, that's my result. But what I'm going to do, because CXE would state in the instructions most times to put the radio instructions to represent, if they do not specify, most times you are required to represent your answer correct to 3 significant figures. So they didn't specify anything here, they just ask you to using a calculator, calculate. Okay? And what I'm going to do now is to represent my final answer correct to 3 significant figures. Of course, we're going to be looking at significant figures later on in the session. But to round correct to 3 significant figures, for significant figures, what we do, we always count from the first non-zero digit when you're rounding. You count from the first non-zero digit from the left. So the first non-zero digit from the left, moving from left to right, the first non-zero digit here is 2. So you're counting, you're not moving the point. Students like to move the point. You're not moving the point, you're just counting the positions. So it's 3 significant figures. So I count 1, 2, 3. That 9, first 9 is my first, that's my third, significant figure. So what do I do to help to approximate? I look at the number immediately after, which is this 9 here. And if the number immediately after is 5 or more than 5, then the number before, which is 9 in that case, becomes 10. And the 1 and 0 in my 10 has a purpose. The 1 from my 10 I'm going to add to my 3 to become 4. And the 9 that I have underlined, I'm going to replace that 9 with a 0 from my 10. So this will become 2.40. Alright, the 3, and I'll put in brackets, the 3 significant figures. So we'll be aware that is what we approximated it to. Okay? So ensuring that, when we are given questions as such, if they don't specify what we do, you can put on all of the digits. When you place it into the calculator and when you get the final answer, you can approximate correct 3 significant figures, which they often require you to do as indicated in the instructions. Okay? Alright, let's look at next. Right, using a calculator, otherwise again, calculate the exact value of that. Again, using the calculator, showing steps. So I show my steps, show steps. So we have here right, 12.8 in brackets squared. Subtract 30 divided by 0.375. So what we're going to do, we're going to work out 12.8 by 12.8. That's what 12.8 squared what means or represents. So this will be 12.8 times 12.8, and I put 12.8 by 12.8 in brackets. Subtract 30 divided by 0.375. So let me work out 12.8 by 12.8. So I go to my calculator, 12.8 times itself. That will give us 163.84. Subtract 30 divided by 0.375. That's 30 divided by 0.375. And we're going to get 80. And at this point, we're going to subtract 80 from 163.84. So let's move that out. 163.84. Subtract 80. And we're going to get 83.84. Straightforward. Easy marks in the bag. So show steps. And once you show steps, you will certainly be given your marks, even though you are asked to use the calculator. Alright? Okay, so let's look at these two quickly. And then we are going to move on to indices next. Okay, so we're going to look at indices next. So going through some of the key topics on the number theory that we need to know to strengthen our knowledge and understanding. Of course, we have more topics to learn. So next week, I'll just do a quick review of other topics. But remember, from now straight until exams, every Saturday, I'll be, going through all the topics that we need to know to prepare us for the exam and doing examples, questions to make sure we're clear. And we have the trivia to test our knowledge after, right? So we have that exercise to do. Like I said, we can get the link in the description in the YouTube channel. Okay, so you can access it. So you go to, it's under Math Mania, and you go to see the examination, okay, or the assessment. So we have here using a calculator, otherwise we have 5.24 and in brackets 4 subtract 1.67. Of course, straightforward. We know when we see 5.24, there is no operation separating the 5.24 and brackets. So we know that's 5.24 multiplied by the result of 4 subtract 1.67. So let's work out what is in brackets first. So this will be 5.24 and 4 subtract 1.67 will give me 2.33. And what I'm going to do is to multiply 5.24 by 2.33, which will give me 12.2092. Yeah, easy marks at the back. Part 2, we have 1.68 over 1.5 squared subtract 1.45. Of course, we're going to work out what is 1.5 squared first to make sure we know what that is. So this will be rewritten as 1.68 all over 1.5 by 1.5. That is what 1.5 squared means. We're going to get 2.25. Subtract 1.45. Let me subtract 1.45 from 2.25. That will give me 0.8. So this will be 1.68 divided by 0.8. And when I divide those two, what are we going to get? We are going to get 2.1. So straightforward use of the calculator, showing steps to help us to arrive at the desired result. Okay? Alright. So we move on next to indices, another very important topic you will see indices in algebra. Of course, you have indices under number theory and applying the rules of indices, making sure we are familiar with all the rules of indices. So that's a bit here. Right, so check indices. Okay, so we have, so I'm not going to go through all, I'm just going to simply look at the rule, the application of the rule, and note the rules will apply to algebra. When we get into the algebra, and we are seeing where indices will come into play under the algebra component, ensuring that we understand the rules of indices. So, one, this here is the rule of multiplication. So indices, and we're going to do the rule of multiplication. So one, we know the rule of multiplication. So rule of multiplication, by indices, will be a to the power of m by a to the power of n. We know what we do. Once you have the same base, because an index is a power, but it's attached to a base. Once you have the same base, you maintain the base A, and the powers you add. Good? So we have here 1, looking at 1, all of the same base. Each base has a power of 1. So you know this is 2 by 2 by 2 by 2 by 2 by 2 by 2. So this will be, we have the same base, so we maintain the base 2, but each base has a power of 1. And we add the powers to give us what? 2 to the power of 7. So remember that rule of indices for multiplication. 2, I'll do 4. This will be 9. How many 9s? 1, 2, 3, 4, 5. But 7, let me go with the last. Let's do 5. How many 7s? 1, 2, 3, 4, 5, 6, 7, 8, 9. So you know that this will be we have the same base, we multiply, we maintain that base. Each base has a power of 1. So we add all to give us, all the powers to give us 9. Straightforward, our rule of indices for multiplication. Let's move on to the next. We're looking at division, making sure we remember, and please remember your rules, rules of division. So going through all the rules help us when we get to the algebra and we see indices, we can apply our rules competently. So division, we know what is a rule. If we have a to the power of m divided by a to the power of n, once we have the same base, we maintain the base a, but we subtract the powers. The power of the first term subtract the power of the second term. Yeah? Or the power of the first quantity. These are quantities. Power of the first quantity subtract the power of the second quantity. So we have, and I'll just do 2. Let's go with 31. This is 6 to the power of 7 divided by 6 to the power of 4. We have the same base, so I maintain my base 6. And I subtract the power, so it's going to be 7 subtract 4, which will be 6 to the power of 3. Alright, and we're leaving the answer in index 4. If I have, say, let's go with 35. 10 to the power of 30 divided by 10 to the power of 8. Again, we have the same base we're dividing, 10. Alright, same base, we maintain the base, 10. And the powers you subtract, 13 subtract 8, which will give me 10 to the power 5. Straightforward. Leaving the answer in index form. Straightforward. So let's move on to the next rule. Right, important rule known as the rule of power to a power. So the rule of power to a power. So again, I'm just doing 2. If I have 51, I have 5 to the power 3, all to the power 4. This is power to a power, where I'm taking the power outside and I'm going to multiply by the power within. Yeah, that's simply power to a power. Or if you want to write this, which will be the same result, 5 to the power 3 is to the power 4, is 5 to the power 3 by itself 4 times. This is one way of doing it, if you want to do it like this. So therefore, when you multiply and applying the rule of multiplication, you have the same base, you maintain the base, and the powers you add. 3 plus 3, 6 plus 9 plus 3, 12. Or the other approach, or the easy approach, will be you take the power outside and multiply by the power within. So this is 5 to the power of 3 by 4, 5 to the power of 12. Make sure you know that rule of power to a power, because you're going to see indices in your algebra also. You want to make sure you know your rules. Alright, let's look at, I'll do 55. 9 to the power of 2, 1 to the power of 8. Again, power to a power. I take the power outside and then multiply by the power within. This is 9 to the power of 2 by 8. 9 to the power of 16. But if you want to write 9 by 8, 9 to the power of 2 by itself 8 times, you're going to get the same answer. Okay? So the rule of power to a power. Alright, let's look at another rule of indices. The easiest rule of them all, of indices, the easiest one. So, we have what? The rule of the zero index of power, zero index. The rule of the zero index. And straightforward, I'll go with, let's go with 71. Well, let me write the rule first. The rule. If I have any base raised to a power of 0, the answer is automatically 1. Simple rule. So I know 71 will be 9 to the power of 0, whose answer is 1. I know 73, 127 to the power of 0, whose answer is 1. I can have a million raised to the power of 0, my answer will always be 1 once the power is 0. So remember that, don't forget that. Alright, let's move on to the next rule. Right, so we're looking at the rule of the negative index of power. When the power is negative, how do we treat with a power that is negative? So normally when the power is negative, what we often attempt to do is to move it from a negative power to a positive power. Alright? So what do we do? But let's take what's the rule first. So we're looking at the negative index. So when the power is negative, what do we do? Now what's the rule? If I have a to the power of negative m, and I want to move that from a negative power to a positive power, what is the rule? What you always do, you're going to put 1 all over, always 1, not 2, not 3, not 4, always 1 all over. I maintain my base A, and my negative power becomes a positive power. So 1 all over A to the power of M. That's the rule of the negative index. So the power is negative, this is what you do. You put 1 all over, let's put 1 all over. Keep the base and the negative power becomes positive. So if you have, let's look at 76 and 77. 5 to the power of negative 4. Again, what you're going to do, you want to move it from a negative to a positive index. Put 1 all over 5 and negative 4 becomes positive 4. And that's what we wanted. Alright? Unless they ask you to simplify it further, which means you multiply 5 by itself 4 times and you get a value for that. So put 1 all over that value. But we leave it in the next form. Right? So if you have 77, 7 to the power of negative 5. Again, what are we going to do? 1 all over 7 and negative 5 becomes positive 5. Make sure we know the rule to guide us. Okay, let's look at this time we're moving from a positive index. So doing the reverse. We're moving from positive back to negative. We went from negative to positive, but you can do the reverse as well. Where you can move from the positive index in the denominator, and you can move from the positive index to negative index. You have the reverse action as well. So you have here still on the negative index, but the reverse action. So you move it from here back to, so you're moving that A to the M power, positive M in the denominator. When you move it up to the numerator, that power, positive M, becomes negative M. So if you have 81, 1 over A to the power of positive 3. Make sure you're going to use rules there, make sure you go there. What you're going to do, you're going to move A to the power of positive 3 from the denominator to the numerator, so 8 stays as 8. But positive 3 becomes negative 3. So that's just doing the reverse, moving from a negative, from a positive to a negative index. If I have 82, 1 all over 10 to the power of 5, and I want to move that from a positive index to a negative index, what's going to happen? I move my 10 from the denominator, 10 to the power of 5, from the denominator to the numerator. So your base 10 stays as is, base 10 stays as is, but positive 5 becomes negative 5. So this is the reverse of it. So make sure we understand the law of the negative index. So we move from negative to positive and the vice versa. Alright? Okay. Let's look at the last law of indices where the power can be a fraction. So, we're looking at the law where the power is a fraction. So the power is a fraction. Good? So the power is a fraction. What is the rule? If I have a to the power of 1 all over m, but this is important to note. When the power is a fraction, note that power, what normally happens, the root symbol will come into play. This is your root symbol. Alright? And that root symbol can be square root, it can be cube root, it can be fourth root. The order of the root is identified when we place a number here. If it's square root, 2 is understood, so we don't necessarily write 2 because it's understood. If it's cube root, we're going to place a 3. And we see on our calculators too, if it's fourth root, you see 4, fifth root, so you place the order of the root, you place a number outside of the root symbol. So, if we have a to the power of 1 over m, note that the root symbol will come into play. This is what I do. I put my root symbol, a the base will be placed under the root symbol. 1 the numerator of the fraction, which is your power, the numerator becomes the power of a. And the denominator becomes the order of the root. Very important. So 1, the numerator of the fraction, becomes the power of the base a, and the denominator of the fraction becomes the order of the root, whether it's square root, cube root, fourth root, whatever. Alright? So let's pick one of these, and of course there are 2 ways of getting the same answer, right? So let's pick one. Let's go with 16 to the power of half. So I go 87. 16 to the power of half. Yeah? I can write this, and again you can use a calculator. 2 ways I'll show you. This will be bringing your root symbol, 16 the base, it's placed under the root symbol. 1 the numerator of your power, that's a fraction, becomes the power of 16. 2 the denominator of your power, that's a fraction, becomes the order of your root. So that really is square root. And the square root, this is the same as the square root of 16, which is equal to 4. Straightforward. If you have, let's go with 95. Alright, I'll circle 87, I'll circle 95. Then we have here I have 343 and I have to raise the power of a third. Now note, what can we do? We can express this as 1, I have my root symbol. So once the power is a fraction, that root symbol will come into play. Of course, 343 will be placed under the root symbol. 1, which is the numerator of your fraction, becomes the power of 343. 3, the denominator of the fraction, becomes the order of the root. So that there is a cube root of 343. What you can do is go to your calculator. You have second function. There's cube root on your calculator. So you see the root symbol and 3 outside. And the cube root of 343 will give you 7. Then let's take another. Let's take 98. 125 to the power of 2/3. Right? I'm circling. I'm just doing 3 because then I will show you as well another approach you can use to get the same result. So if you have 98. We have 98. We have 125 to the power of 2/3. What do we do? Again, once the power is a fraction, the root symbol comes into play. So this will be root symbol, 125 is placed below the root symbol. 2, which is the numerator of your power that is a fraction, becomes the power of 125. 3, which is the denominator of your power that is a fraction, becomes the order of the root. So it's the cube root of 125 squared. So all you have to do now is work out 125 times itself, which will give you, this is the cube root of 15625. So you go to your calculator and you work out what is the cube root of that. And we're going to get here 25. Yeah? But what I will do is to show you, taking those same 3 examples, and then show another approach we can use to get the same result. So we have this other approach. So it's going to talk about, going back to 87, 16 to the power of a half. I can express the base 16 as a base and power. 16 is the same as 4 squared. And that's 4 squared raised to the power of a half. And what I'm going to do here is apply power to a power. I take the power outside a half and I multiply by the power inside, which is 2. This will give me 4 to the power of 2 times a half. 4 to the power of 1, which is 4. So same answer, so I got 4. I can have here, same result, let's go 95. (343) to the power of a third. Yeah? I can express 343 as 7 to the power of 3. If you multiply 7 by itself 3 times, you get 343. So 343 is the same as 7 to the power of 3. But I place 7 to the power of 3 in brackets and I maintain the fraction power of a third. And all I have to do now is apply the law of power to a power we learn. Multiplying a third, the power outside, by the power within. So this becomes 7 to the power of 3 times a third, 7 to the power of 1, which is 7. And let's look at 98 doing the same thing. (125) to the power of 2 thirds. We got 25 previously when we used the cube root symbol. So let's see how we are going to get the same result by using this other approach. We can express 125 as a base and power. 125 is the same as 5 cubed. Multiply 5 by itself 3 times, you're going to get 125. So 5 cubed, 4 to the power of 2 thirds. And I'm going to apply my law of power to a power. I'm going to take the power outside 2 thirds and I'm going to multiply by the power within, which is 3. So I'm going to get 5 to the power of 3 times 2 thirds. 3 times 2 thirds will give me 2, so I'm going to get 5 squared, which is 5 by 5 to give me 25. Alright? So these are some important laws, the laws of indices we want to make sure we are comfortable with. Alright? Alright, so, okay, so let's move on to percentages. Alright, so you see, of course, a number of questions in the CTEC exam where percentages are involved, and we want to make sure you understand your percentages. Now we know when it comes to percentages, we do the symbol for a percentage. You have X and that's your percentage symbol. Do that. Okay? And we know a percentage can be represented as a fraction by simply placing X in this case all over 100. Good? Simple, that's a percentage. So, if we have to express the following as a percentage, straightforward, we know this will be what? To express 7 over 15 as a percentage, we know as what? 17 over 15 times 100. Yeah, straightforward. And I'm going to say what? 5 into 15 is 3. 5 into 100 is 20. And I know 17 by 20 will give me 340. And 340 divided by 3 will give me what? 3 to 3 is 1. 3 to 4 is 1, remainder 1. 3 to 3 is 9, that's 110. So I'm going to get 113 and a third percent. That's expressing 17 over 15 as a percentage. Simply 17 over 15 times 100. Okay, let's look at another. Right, 0.485 as a percentage, easy. Again, 0.48845 times 100. And when I multiply by 100, what's going to happen? I'm going to move my point 2 places to the right, so it becomes 84.5%. That's it. 84.5%. Move your point 2 places to the right and multiply by 100, and that's your answer. Straightforward. Let's get another. So this time we have a percentage, and I want to convert that into a decimal fraction, a fraction. Okay? So we're going to convert that into a fraction. So we have 16.5%. Remember, a percentage, it is a fraction. So what do we do? 16.5, let's convert that from a mixed take proper. That's 2 by 16 is what? 32. 32 plus 1 will give me 33 all over 2%. But 33 all over 2% is the same as 33 all over 2 all over 100. Yeah? Remember we had x percent, put x all over 100. 33 over 2% is 33 over 2 all over 100. Which is the same as what? 33 all over 2 divided by 100 all over 1. Yeah? Which is the same as 33 all over 2 multiplied by change division to multiplication and invert to become 1 all over 100. And this becomes 33 by 1 is 33. 2 by 100 it's 200. So you have 33 all over 200. Yeah? And that is simply converting a percentage back to a fraction. Alright? And of course we can do the vice versa. Right, expressing one quantity as a percentage of another. If they ask you to express 4 millimeters as a percentage of 3 centimeters, it got something like this. Yeah? Then 4 millimeters as a percentage of 3 centimeters. Now, if I have to express one quantity as a percentage of the other, then both must be of the same units. So I can't express one quantity as a percentage of the other and the units are different. So I have to make sure the units are the same. So if we want, we can convert to the smaller unit, which is millimeters. Millimeters is smaller than centimeters. So if you want, you can convert 3 centimeters to millimeters. Okay? And note 100 or 10 millimeters is equal to 1 centimeter. Right? That's the relationship between millimeters and centimeters. And if I have to go from 3 centimeters to millimeters, I'm going from 3 centimeters to millimeters. I'm going from a bigger unit to a smaller unit. And also remember, when you're moving from bigger to smaller, what you do is you multiply. Right? So from a bigger unit to a smaller unit, you multiply. From a smaller unit converted to a bigger unit, you divide. So if I have to move from 3 centimeters to millimeters, I'm going to multiply 3 by 10, which will give me 30 millimeters. So 3 centimeters, it is really equal to 30 millimeters. So if I have to express 4 millimeters as a percentage of 3 centimeters or 30 millimeters, then this would be 4 over 30 by 100. Which will give me 0,400. 10 by 4 is 40 all over 3. And 40 all over 3 will be what? 3 into 4 is 1. Remainder 1. 3 into 10, 3 3s are 9. Add 1 10. So we're going to get 13.3%. Alright? So expressing one quantity as a percentage of the other. Alright? Let's look at evaluate 22.5% of 40 meters. Twenty-two and a half percent of 40 meters. This is 22.5% of, which means to multiply 40 meters. Okay? So what do we do? Because all these are questions, you see the multiple choice. Yeah? So you see the structured paper too, but a lot in the multiple choice. So this will be, let me convert that 22.5% from a percentage to a fraction, and I'll multiply by 40. So this is 2 by 22 is 44, plus 1 gives me 45 over 2% times 40. 45 over 2% is the same as 45 over 2 all over 100, which is 45 all over 2 divided by 100 over 1, which is 45 over 2 multiplied by 1 over 100, which will give me 45 all over 200. And I can simplify 5 can go into 45, 9, 5 can go into 200, 40. Yeah? So we're going to get here 9 all over 40. So let's multiply 9 over 40 by 40. And we're going to get here 9. Straightforward. Very, very straightforward. Yeah? So percentages. Right, let's look at some problem solving questions. Of course, these are questions you'll see in the multiple choice, right, of the exam paper. There are 530 students in my school and 30% are footballers. How many students are not footballers? If 30% are footballers, then let's find 30% of 530. So 30% will be 30% of 530. That's 30 over 100 of 530, which will give us what? 0 go, 0 go, 0 go, 0 go. So 53 by 3 will give us what? 159. Right? So these are students in my school who are footballers. So 159 will be footballers. So non-footballers will be to subtract those who are footballers from the total number of students. So that will be 530 subtract 159, that will give us what? 530, 371. So 371 will be your non-footballers. Alright? Again, show where percentages will come into play. Let's look at another. A test was marked on the weighting. Again, you know, a lot of these are multiple choice questions, and you see sometimes instruction. A lot of instruction. A boy scored 60%. A test was marked on the weighting. A boy scored 60% of the marks on the test. How many marks did he score? Straightforward. So 60% of the marks, that's 60 over 100 times 80. So 48 marks he scored. 48. Straightforward. Yeah? Let's take another. What percentage of 30 is 6? Another multiple choice question. Right? What percentage of 30 is 6? So if we have to figure this out, we can simply use our knowledge of equations can come into play here. What percent? We don't know that percentage, let's call it X percent. Of 30 of these to multiply is 6, is equal to 6. We want to solve for X. What is X percent? What percentage of 30 is 6? X percent is the same as X all over 100. I can convert that now into a fraction. Times 30 is equal to 6. This will be 0 cancels with 0. I'm going to get 3x all over 10 is equal to 6. 3 by x will give me 3x. Of course, this is 30 all over 1. 10 by 1 is 10. So I'm going to get 3x over 10 is equal to 6. Now what we have here is a simple equation, and again we are going to be reviewing our algebra, and to solve our equation like this is 6 over 1, and we can cross multiply to remove it from the fraction. So 1 by 3x is 3x, 10 by 6 is 60, and therefore to get x by itself I'm going to divide both sides by 3. X is 20. So 20% of 30 will give us 6. Yeah? So what percentage of 30 is 6? That's 20%. Alright? And making sure we understand the step that was carried out here to help us to determine that. There are 40 students in a class. Girls make up 60% of the class, 25% of the girls wear glasses. How many girls in the class wear glasses? Again, another multiple choice question. Again, you see something like this, sometimes you see questions like this in the structure. So we have here students in a class, girls make up 60% of the class. So let's determine how many girls. 60%, right? Times 40 will be 60 all over 100 times 40. So let's work out that. 60 over 100 times 40. 0 goes, 0 goes, 0 goes, 0 goes. That's 24 girls. So you have 24 girls out of the 40 students, 24 girls. 25% of the girls wear glasses. 25% wear glasses. How many girls in the class wear glasses? So, glasses, 25%, so that is what? 25 all over 25% of 24. 25% of the girls wear glasses. So this will be 25 all over 100 times 24, which is a quarter times 24. So 6 girls wear glasses. Good? Straightforward. So percentages, pretty straightforward. Alright? If we have here, again percentages, a dinner at a restaurant was advertised at $60 plus 18% tax. The total bill for this dinner was, another again, question you see in paper 2, mostly multiple choice, this is what? Right, so 60% plus 18% tax. So the tax will be 18% of 60, 18 over 100 times 60, which will give us what? 0 go, 0 go. 2 into 10, 5, 2 into 6, 3. 18 by 3 will give us what? That's 54. 54 divided by 5, that will give me 5 into 5 is 1. 5 into 4 is none, so you're going to get 10 and 4/5, which is the same as 10.8. So the tax was really $10.80, right? So the 18% tax on that $60, if you remember your people go to buy food, they will charge $60, obviously. They will charge, tax will be added onto that. That's all sales tax. So therefore, the total bill for dinner will be to add to your $60, $10.80, which will give you $70.80. Alright, percentages, reviewing the percentages, making sure you remember our percentage as well. Right, let's look at this again. A car presently valued at $12,000 depreciates at the rate of 10% per annum. What will be the value of the car 1 year later? Depreciates, right? So therefore, if it's valued at $12,000 at the beginning of the year, you know at the end of the year or a year later, we expect it to be $12,000, right? It's a car, can't depreciate, right? So this will be so your depreciation will be 10%. Percentages come into play here of $12,000. That's 10 all over 100 times 12,000, 0, 0, 0, 0. That will give me 120 by 10, which is $1,200. It's going to depreciate by the value of the vehicle. So therefore, what will be the value of the car? So the value of the car 1 year later will be to subtract $1,200 from $12,000. And when we subtract those two, what are we going to get? Yeah? So you can work it out just to save time. 10,800. Will be the value of the car 1 year later. Alright? So pretty straightforward. Pretty straightforward. Alright, so let's quickly look at decimal places and rounding. So let's look at that. Alright? Or if not, because what I intend to do, I intend next week to look at remember every Saturday from now onward, I will be, until exams, I'll be doing revision exercises, alright? So again, tell your friends, come be a part of the sessions and benefit from all that will be done in preparation for the examination. Alright, so let's quickly look at the last thing here, which is decimal places. After decimal places, we have significant figures. There's standard form, there's a ratio and proportion. So I'll leave those for next week. Okay? Let's look at decimal places as the last of today's session. Right? So we have here so we're rounding. So we want to round each of the following numbers correct to one decimal place. I'm not doing all, I'm just picking one. So if you have to round correct a number of decimal places, we must count from that first digit after the decimal point. Straightforward. So if you have A to around 4.82 correct to one decimal place, and with a count, don't move the point, but count the position after the point. 1. I look at the number immediately after. It's always important to look at that number immediately after, which is 2. It's a less than 5, so my 8 stays as it is. So this will be equal to 4.8 to 1 dp. Let me take another. If I have B, 9.77 to 1 dp. I count one place after the point. I look at the number immediately after, which is 7. In this case, once the number immediately after is 5 or more than 5, I'm going to add 1 to the number underlined, so that 7 becomes 8. Right? Straightforward. Round each of the following numbers below correct to 2 decimal places. The 2 decimal places we have A 3.487 to 2 decimal places. You have to round that to 2 decimal places. This will be, and we put the approximation symbol for that symbol. So to 2 decimal places, I count 2 places, or counting, don't move the point. 2 places after the point. 1, 2. I look at the number immediately after, which is 7. Once it's 5 or more, I add 1 to that 8 to become 9. Alright, let me choose another. Let's look at D. 10.046. 2 decimal places. I count 2 places after the point. 1, 2. I look at the number after, which is 6. Once it's 5 or more, I add 1 to my 4 to become 10.05. Right? And these are the 2 divisions. Both the 2 decimal places. Alright? So let's look at here. 51.26% of people living in a town are female. Round this figure to 1 decimal place. So 51.26% of people living in a town are female. Let's round that to 1 decimal place. So it's a percentage, and we know a percentage can simply represent a percentage as a fraction, but then it's 51.26%, which is the same as right, I want to round this figure to 1 decimal place. Let's round that figure to 1 decimal place. So to round that figure to 1 decimal place, that will be what? That will be, I count 1 place after the point, which is my 2. I look at the number immediately after, which is 6. Once it's 5 or more than 5, I add 1 to that 2 to become 3. So 51.26% becomes 51.3, round to 1 decimal place. Yeah? Straightforward. Simple approximation. A chocolate bar contains 0.4715 grams of salt. Round this to 2 decimal places. So to 2 decimal places, again, I count 2 places after my point. So I count 1, 2. I look at the number immediately after, which is 1. It's less than 5. So my 7 stays as is. Straightforward. Make sure you can round correct number of decimal places. That's going to say. Using it R. So, right. So this was the question we did previously, but I would have left out how many decimal places to round to. Right? So they did ask you to round. So to 2 decimal places. So let's work it now where we're going to round to 2 decimal places. So this will be the square root of 2.891 plus 1.2 all over 1.31 squared. So again, what did we do? We found the square root of 2.891. We're going to get 1.700294,092 plus. I'm going to put out all the values. Let me work out 1.31 by 1.31. I've already did that previously. This will be 1.2 over 1.7161. So let me divide those two quickly. So dividing those two quickly. So this will give me 0.699259949. Let me add those two. Let's see what we're going to get. Right, so we're going to get 2.399554042, and now let's approximate this time to correct the 2 decimal places. So I count 2 places after the point. 1, 2. I look at the number after, which is 9. 1 to 5 or more than 5. I add 1 to this 9 to become 10. And what happens? 1 from my 10 I add to my 3 to become 4, and I replace that 9 with 0. So this is 2.40, 2 decimal places. I think we got the same result too when we approximated to correct the 3 significant figures. So 3 significant figures will give us the same result. Alright? Alright, let's look at this one here. We have 2.86 plus 0.75 plus 0.481 squared. You know what is 0.481 squared and 0.481 by itself, right? So let's work out what is in brackets first. That's 2.86 plus 0.75 will give us 3.61 plus 0.481 by 0.481 will give us 0.231361. Yeah? And now let's add those 2 plus 3.61 will give us 3.841361. And now let's approximate that answer correct to how many decimal places? 2 decimal places. So we count 1, 2. Second decimal place, my 4. I look at the number immediately after, which is 1. Once it's less than 5, your 4 underline stays as is. So you're going to get 3.84. Correct to 2. Straightforward. Make sure your approximations rounding correct a number of decimal places. You're comfortable with that. Alright, so we're going to end the session today. Remember, we can access the trivia, so you can go to the description. You're going to see the link to the trivia, and it's under the Math Mania section. And you can attempt the trivia to get practice and to strengthen your understanding. Remember, now is the time to start pushing yourselves. Now is the time to ensure that you lay the foundation as you prepare for your exam. Before you know it, it's January. The time, it's going by very quickly. Before you know it, it's going to be, CSEC time, and we want to ensure that we're ready. So invite all your friends to be a part of the sessions on Saturday, as we'll be reviewing all topics in preparation for the examination. Alright? So, with that said, everyone, have a great evening, and I'll see you next week. Take care, everyone.